Mentally math!
Let's get mental!
Alright.
Done. All right, that you do good.
Oh, thank you. Thank you. Okay. Just to say, if you are watching this video at home, we have just spent some time watching some videos off of the math playlist. So if you haven't gone there yet, you should go there first. So you should leave this video, you should go to the math playlist and watch the 3 videos I have there. Okay?
Yeah, then come back here.
Alright, so get out of here!
Yeah, get out.
Get out. Okay, come back soon. Okay, we're gonna be quiet here for a minute while you leave and come back. I said we're gonna be quiet. Welcome back. Mentally math. Let's get mental.
Yay.
Why are we laughing?
No reason.
Okay, gonna give you a couple minutes. Get out of me. Yada yada yada. What is that? I mean, yada yada yada.
What? I'm laughing because there's no laughing. Laughing is funny. I'm just laughing because
Okay then.
Guys! Stop it! I can't stop laughing. You can't stop laughing. Oh my god.
Oh my god.
Okay, I'll assume people at least a couple out ahead of me at this point.
Me.
So here we would have a negative value to a positive 45. So that's essentially combining a negative value of 45 and negative 30, giving us, let's make it clap, giving us negative 75. And then I can kind of think of this as 4 times 4 times 100, right? 1,600.
That's right.
Oh, right on. And then add 4 to the 36 gets me 40, divided by 5 gets me 8. Then 15 is 3/5 of n, so I'll divide 15 by 3, getting 5, then times 5 is 25. Then metric conversions. So 1,000 kilos, 1,000 units make a kilo. So that's 1 and 5/10 kilometers. Then 3/5 of 15. So in this case, I'm going to divide 15 by 5 to get my unit and multiply that by 3 to get 9. And then, I'm liking these since this one's in the middle and they're sequential, so we can just say the median is in fact the average or the mean.
Finally not 80.
And it's finally not 80.
Yeah.
Okay, so for the perimeter, it would be 1.5 times 4, so that'd be, oops. Okay, didn't mean to grab you. Would be 6 meters. And the area, basically 15 squared divided by 100. So get me 2 and 25th 100 square meters, I believe. Okay. All right. So today we are talking about Transformations! Blah! Alright, so if you've already watched the videos from the math playlist, then you've already had the ideas here gotten across. So our first one here, we're going to talk about reflection. And you are going to make some coordinate planes. I am also going to make some coordinate planes because that gives me an idea of about how long you should take.
You already have them. Yeah,
So let's all get to work on this, making the coordinate plane.
I like coordinate planes.
Oh, that's good.
Yeah, one gave me a trip to
1,
my
2, 3, 4, 5, 6. Okay, and then going to.
There's 4 examples and 4 kinds of transformation.
Yep.
Mm-hmm. And
5, 6. Then
I'll find out
negative,
first.
negative 2, negative 3, negative 4, negative 5, and then negative 1, negative 2, negative 3, negative 4, negative 5, but we don't really need all of that. Alright, and I'm going to start out by making my first triangle, RST, and then we'll talk about how to transform it using a reflection across the x-axis. And I'm gonna color code and try to make this as.
Actually, I'm pretty sure we did something like this before. Like they didn't exactly call it, but it sounds like.
Okay, so here's my R. Whoop, no, that's my T. Excuse me. Here's my T. And then let's see, we'll make R red. So that will be at 4, 3. And then
Wait, is it on both axes or just one axis?
well, we're going to start out on one axis. Okay, so R, and then S will make you green, is at 4 what? Alright, and I will attempt to make you into a triangle, though this thing's been rather finicky today. Oop, forgot to label it. T. Ta-da! Okay. There we go. I've got my R. Oh, whoops! Oh no, I keep on. Why do I keep doing this? Okay, excuse me. Keep mislabeling these things.
Mr. Griffin?
What?
So, actually, no, I'm going to save it for when we actually do it.
Alright. Okay. So, there we've got RST as opposed to RTT, which was very confusing. And so we're starting out with our first untransformed triangle. So the clue here is that it is telling us to do our reflection across the x-axis. So here's the rule for what this means, and I'm gonna try to kind of give you a simplified explanation. But I'll start by kind of showing you and what I'm going to do if I'm reflecting across the x-axis, and then I'm going to try to give you like the simple rule to remember.
Wait, wouldn't it be reflecting across the both x and y axis? Basically, just be rotating it one to the other? Yeah.
You were asking about that. That's not what we're doing right now. Alright, so when it's saying to reflect across the x-axis, well, here's your x-axis. And so that means you are reflecting that-way.
What? That one?
I thought it meant the opposite.
Exactly. So basically, all of your y coordinates are now going to be negative of what they were.
Why
Okay?
Are you changing it?
So,
Why are you changing it?
why might? Because that's what the example says to do. That's why I'm doing this. So, so essentially our t, we're going to make that one, and well, that's sort of the one that's changed the least. But so instead of 1 1, it's 1 negative 1. Because when it's saying you're going across the x-axis, that means you're going, well, across the x-axis, right? So essentially you're making all of your y coordinates, no, just negative of what they were. So hold on, let me do one more, or let me move these over, and let me kind of try to give you the simple rule. Okay, so now my r is, since that's 4, 3, it's going to be 4, negative 3 for my transformed one. Because I'm going across the x-axis. And then finally for my s, since that one is at 4, 1, it's going to be 4, negative 1.
Wait, is reflection the one where you kind of flip it?
Yes. It's kind of flipping. So it's sort of like imagine this triangle is looking down into a pool of water and it's looking at its reflection. Whoops.
That makes sense.
Okay, so that's what that's going to end up looking like. And then what we do is shorthand to say that it's been transformed is we give it a little sort of it's almost like kind of an apostrophe, or almost like the symbol for like feet.
Is that inches?
No, 2 would be inches, wouldn't it?
I didn't think of it.
Okay, and then so there will be my R, my transformed R, and then it's my transformed S. So they all have that little mark there. Okay, so when we're talking about reflection and we are saying that you're reflecting across the x-axis, basically the axis that it says you're reflecting across, that's the coordinate that you leave alone. That's the non-intuitive thing. That's the thing that might be a little hard to remember, but think, okay, if you're reflecting across an axis, you leave that coordinate alone. So if it says reflecting, I do see you, just let me finish speaking. If you are reflecting across the x-axis, that means you leave the x-axis alone and you make the y-axis negative of whatever it already is. If you're reflecting across the y-axis, then you leave your y-coordinate alone and you make your x-coordinate negative. So the axis that it's saying to reflect across, that's the coordinate that you don't do anything to.
That it makes. Wait, can I? So I get it, but it's just hard to remember because that just like it's confusing. It's not what you would normally think.
Right. That's what we would say. It's non-intuitive, and so it's something we can practice.
Wait, I don't get it. What do you mean? What are you leaving alone?
I'm leaving my x coordinate alone. So my transformed t. It's still a 1 x coordinate.
Oh.
My transformed s its x-coordinate is still just 4.
Wait, I thought
Right?
the x-coordinate.
None of the, since we're going across the x-axis, none of our x-coordinates have been changed at all. Only the y-coordinates have been made negative.
Oh, does it always have to say in reflection to this axis?
Yeah, because if you'd like, I did it this morning too. It might be a good exercise. How about everyone? Why don't you try doing this again, reflecting across the y-axis? Try this again. Now, this is what this looks like. We're going across the x-axis. Try making one that's across the y-axis. So, if we're making across the y-axis, that means we are not touching, we are not doing anything to our y-coordinate, but we are making our x-coordinate negative.
I wanted to think of it even okay.
Okay?
If you're going across the x-axis, you're looking down a puddle. If you're going across the y-axis, you're looking in the mirror.
Okay, that's a cool way of looking. So this time we're going that way.
Look in the mirror. Wait, is it, don't they, like, when it's listed all like that, like, this, doesn't the x-coordinate come first?
Yes, the x-coordinate comes first.
But if the x-coordinate is 1, it's behind the 4. So isn't it supposed to be 1, 4? Is it 4, 1?
I think you're misreading this. Okay, so this time, my t is going to be it's going to be -1, 1. Right? My r is going to be -4, 3. And my s is going to be -4, 1. Whoops. And so then that's what that would look like reflected across the y-axis. So how are we doing? 1, 2, or 3? How are you feeling? Okay.
That's just weird.
Yeah, it's weird. That's why we're practicing. But you know, it's just a matter of kind of learning the rules for each transformation. Okay, great. And if you're at a 2 right now, that's okay. But I think we're mostly doing pretty good. Okay, so 2 3/4.
Yeah.
Okay, that's fine.
17.
I mean, just introducing this, that's not bad at all.
But the
All right, so make yourself another coordinate plane. And so this time we're doing translation. Translation's pretty straightforward, actually.
I've just got one question.
Uh-huh.
When it's listed in the problem, the coordinates, which is the x one and which is the y?
X is always the first coordinate, Y is always the second coordinate.
So in vertex CA, the coordinates are, the x coordinate is 4.
Sorry, one more time?
And for A, like.
Oh, yeah, so for A, it's X coordinate is 4, Y coordinate is 3.
Oh, okay.
It's always X, Y, always.
Okay, that makes sense.
I'm trying to write my numbers really small so that they don't get in the way of the other things I draw. Okay. Alright, so there we go. Got my coordinate plane. And so next is to make our rectangle ABCD. And so A is going to be 4, 3. B.
Oh, Mr. Petrie? apostrophe thing only go for does it only go for reflections or is it for all transformations?
All transformations. So as you see, they are describing the translated rectangle as translate A, translate B, translate C, translate D, using the apostrophes. All right, then B for 1, C 1 1, and D. Make you purple. 1 3. It's not a very good job. So we'll call you A. Oops. A. B. C. Oof. Come on, don't be finicky. Okay, that works. Alright, so there's our rectangle, and now the good news with this is it's just following instructions.
Yeah, it is.
For every point, every coordinate, you just look in and it tells you what to do. So every coordinate, you need to move it left 5 units, then down 4 units. Alright, so I'm going to start with A here. Okay, so left 5. 1, 2, 3, 4, 5. And then down 4. 1, 2, 3, 4. So that'll get me. That'll get that one there. And then B, same thing. So 1, 2, 3, 4, 5. And then 1, 2, 3, 4. I'll put you there.
After that, you could just count the.
Oh sure, I'm kind of doing this sort of slowly on purpose just to illustrate. Okay, then here's my C. 1, 2, 3, 4, 5. Then down 4. 1, 2, 3, 4. And then my D. 1, 2, 3, 4, 5. 1, 2, 3, 4. And so there we go. Our transformed rectangle. Yes?
Why would you go down like 4?
Because it told me to. See, it says left 5 units, down 4 units. So every single one of these, I go 1, 2, 3, 4, 5. 1, 2, 3, 4. Oh, sure. There's all. I mean, sure. How
Yeah, when I did it, was like 3, and I did that order. But instead of like doing all of them, I then counted how many squares are across and down, and I just copied that onto the.
Oh, sure. I was kind of making it a little bit more long and drawn out than I needed to, just to kind of walk through the process several times, just to be totally clear what we were doing. Did you still have a question? Okay. All right. So that one's not too tricky, right? Just follow the instructions; it'll get you there.
Yeah. Well, you only have to follow like the first 2. Then after that.
You can figure out where the other points are. Yeah, totally. Okay, make yourself another coordinate plane. So this time we're doing rotation, and this is where it starts to get a little strange. Just saying. And let's see, this one I did for that. Okay, so. So if you're not feeling exactly a 3 on this one, it's just maybe something to practice because the rule for it is a little bit wacky.
Bamboozling.
Hopefully it won't get you too bamboozled.
I like what every single time you say that you all need to do.
And so I definitely cannot resist saying it.
And you know that you get them every time. Because you bamboozle them.
Yeah, they seem rather flabbergasted, if you ask me.
Oh my god. Are you guys okay? What happened?
Okay, enough.
Yeah, like.
Oh, how is it here? Sorry? Your desk? Yeah, sure, go ahead. Okay. So just to give you an idea what we're doing here. So I'm not actually trying to put this like to scale or anything. But you can think of this like this. So this time we're doing rotation. Rotation, which of course means, well, we're rotating it, right? But we are, and it's saying to rotate it counterclockwise. So that means we're both going to rotate it in this direction. And also we're going to be moving it to another quadrant in a counterclockwise direction. Since it says 90 degrees, that is one coordinate that it's moving and one turn. So essentially we're taking this guy and we're bringing it over here and we're rotating, and no, it's not accurately in the right spot it's going to be. So that's what we're going for. Is we're going to start out with it here and it'll end up kind of turning over there. So, I'm going to start out making my original triangle, as I'm sure you're already finished with.
Rotation is the main one on system.
Yeah. Well, you're gonna love it when we get to the actual rule. Yeah, and by that I mean you're gonna be flabbergasted. Okay, so let's see. Okay, so PQR. So P is gonna be 3, 4. All right, then Q is gonna be 3, 1. And then R is going to be at 1, 1. And hope you'll let me do this. Nope. Come on. Give me my triangle. Alright, I'll take it. Okay, so oops, and
Ooh, I like that.
and oh yeah, it's a little bit colored. Let's see, and I need to label him. So PQR. Alright. So I am going to make I'm gonna make a list of my transformed coordinates just to show what we're doing here. So now you can think of it in a way as being one of those things where if you are going across, since I'm going across the y-axis, then it's my x-axis that is going to be getting turned into a negative sign, right? Because I'm going this way, which is going from positive on the x-axis into the negative zone of the x-axis.
Get it? Like, I get which one we have. Like,
So are you wondering how do you know which
I get,
coordinate it's
like,
supposed to land on?
No, I get that, like, which one we need to rotate if we rotate it on the y-axis, but I just still don't get the 90-degree origin thing.
Okay, well, 90 degrees around the origin means is that you are going from one quadrant on the coordinate plane to the quadrant that is next to it. So the 90 degrees basically, and since you're going counterclockwise, it means that you're going from there to there. Okay. And then it also means that this is going to be turned 190 degree turn. Or rotated 190 degree turn. Okay, now here's the fun part. Is we flip the coordinates.
What?
So this is going to be 4, 3 instead of 3, 4. However, my x coordinate also has to be made into a negative sign. And it's not a matter of getting it or not getting it. It's just a matter of remembering the rule.
Okay, this rule is gonna.
Okay, so my cue.
I wasted so much brain power trying to understand that video when I could just do this.
It's going to be 1, 3, because the original cue was 3, 1 with a negative 1. Yes?
I did it by just flipping it visually, and I kind of got the same coordinates as you.
Fantastic! Good job. Yes.
I can do the
Well, I bet there is an intuitive way of figuring it out. Sure. Okay, and then R. Well, 1, 1 flipped is 1, 1. However, I still need to take myself over to the negative zone with that. Okay, so now that I've got that, I'm going to put them where they belong. Alright, so my R is going to be negative 1, 1. Alright, my...
Mr. Peppery?
Yeah?
For every rotation, do you always do this, or does it depend on some of the factors?
What, the flipping it and making one of them negative?
Yeah.
I believe that is kind of the rule for doing this.
But what if it was 180 degrees?
Well, then you would have to do this twice. But that's not what we're doing right now. So let's I'm not that pleased that they use the 180 for that. So that's not part of this lesson. Okay, then for P, negative 4, 3. Oops, keep doing that. Boop, boop, boop. All right, and so there we have. It's been rotated, turned 190 degree, and is migrated over to the adjacent coordinate plane. Yes.
And what if we were doing it clockwise?
Well, it would it'd be the same sort of thing, except in this you would be you'd be going across the x-axis, so you'd be making your y-axis negative, or your y coordinates negative. Okay. So that guy's done. All right, one more. Okay. So we're doing one more of these. So this time we're doing dilation. You actually only need to have one quadrant for this one. Yeah. Because both of the shapes are in one quadrant. That's why. I haven't been putting my 0 just because I haven't really had room for it. 7. Okay, we can go to 8. You don't really need to go past 7.
I just go up to. Okay, I went up to 8.
That's fine. Doesn't matter. Doesn't matter if you have a little extra headroom. Okay. And so for this, making a little table would be useful. Where we show what we're doing for this. And let's see, I'm gonna say here.
What's the dilation?
Okay, so let's see, I'm gonna say, oops, did I? So, say X, Y, and Z. I think that ought to work. Okay, and then, so this will be triangle XYZ, and this will be for transformed X, Y, Z. So I'm kind of having to sort of cram it there. That's meant to be an X, Y, and Z with the little transformation symbols on them, just in case you're wondering what those are. Okay. So, now let's look at our actual statement here. So triangle XYZ has vertices of X is 1, 1, Y is 2, 1, and Z. So 1, 2. And why don't I draw that? Though, as you might be able to tell, it's a very tiny triangle. So okay, that's gonna be X. Y will be 2, 1. Very tiny triangle. Okay, Y and Z is at 1, 2.
I'm not that Google friendly.
Oh yeah, so no, this one's not that tricky actually. Oops. Alright, and then there's oh yeah, teeny bitty triangle. Oh, I just want to pinch his little cheeks. Though it's a right triangle, it's not a cute triangle.
He's right.
Okay, so this has, and they've told us it's a scale factor of 3. So you'll be glad to know that all this means is you take every single coordinate and you multiply it by 3 to get your transformed one. So your transformed X is 1 times 3 is
3.
Someone said 4.
and 1 times 3 is also 3. Then 2 times 3 is. All right, welcome to the 2nd grade. And then 1 times 3 is still 3. And then 1 times 3 is still 3. And 2 times 3 is still 6.
What? That was
Yep.
interesting. They both consist of 2 numbers for both.
Yeah, well, I guess with the teeny triangle, it's right near the origin that made it very simple. Which is good. So yeah, so the only thing you do if you're doing dilation is whatever the scale factor is, just multiply everything by that scale factor. Yes? Well, it's not a matter of getting it or not getting it, it's a matter of remembering the rule. Okay, so this is a transformation called dilation, also called enlargement. Oh, well, basically, these are my original coordinates, right? These are the coordinates after I have applied the scale factor to it for my transformed triangle. You multiply it by the scale factor. If the scale factor was 2, I would multiply each of these by 2. It would be 2, 2, 4, 2, and 2, 4. If it was a scale factor of 4, it would be 4, 4, etc. So you have to know what the scale factor is. In this case, it's 3, so I multiply everything by 3. That's it. Does that help?
That's when the original triangle was so small.
Yes.
Okay, what's the center of dilation?
The center of dilation.
The center of dilation at the origin.
That's just a fancy way of saying that you multiply these all by 3. Yeah, the center of the dilation is at the origin with the scale factor of 3. So essentially, we're expanding out from the origin. All right, so I'm gonna do my transformed x at 3, 3. Oop.
When you were talking, I was looking at this problem, and then I didn't really get it, but then I just didn't know where to start with it. But then when you said multiply everything by 3, I got it.
It all became clear.
And you had to do, but I didn't know where to start.
Okay, well, cool.
Yeah.
That's why we're doing these in class. All right, then next one, 3, 6. Oops. Oh, it's doing that. Ta-da! And there's your dilated triangle.
If the scale factor is 3, and you could you like think of it like it's the bigger triangle is basically 3 times bigger?
Yeah, sure.
Okay.
I mean, yeah, you could think of it that way. I mean, maybe we could do a little bit of calculation to see if we get the area, if it actually works out that way. I would imagine it would. Okay. And that's lesson 80.